Okay guys, so this is a online revision session for my students. Now, the idea of this session is that you should be able to review it back. You should be able
Guys, so
uh, basically, what I'm going to do is go through a number of areas of the GCSE computing exam, and unfortunately, I have turned off live chat, and that was because of the behaviour of some people who thought it would be funny to write inappropriate comments in the box. So if you are one of my students, you are welcome to drop me an email with any questions and it will pop up on my inbox here. So if you are one of my students, you can drop me an email and I will recap and go over some things. So what I'm going to do is I'm going to start off by going over the basics and some reminders of the fundamentals of computer systems. Now, the thing that we need to remember is that all computer systems are used in everyday parts of our life, and the sort of thing that you need to know for the computing spec is you need to be able to define what a computer system is. Now, a computer system is a collection of parts that work together for a common purpose. You need to remember that, okay? And it is usually used to produce something. So it could be to produce something in a factory. So it's usually used to produce something. Computer systems have many inputs and outputs. Now, I will be coming on to computer hardware in a moment. Now, if you are in year 10, parts of this will help you. You'll be able to watch it back. But this is for the year 11 exam that is happening on Wednesday. Now, what I'm going to be talking about is, so you've learned how to define a computer system. The next thing that you need to be able to do is to describe the importance of computer systems in our modern world. Now, computer systems are used on a day-to-day basis for a number of different things. They're found in electronic gadgets, control devices such as washing machines, cameras, burglar alarms, telephones, and in each case, these are computer systems. They have input devices, they have output devices, they have storage, they have processors. So you need to know that you can use computer systems for anything out there, and you may get an exam question on that. Now, one area that we haven't really talked about is what a dedicated computer system is. All right. Now, a dedicated computer system is something that is designed for one specific purpose. So you may have designed it to look at an engine management system in a car. Other systems are general purpose. So I'm going to put the example here for dedicated. So engine management system in a car. All right. But then you've also got general purpose, which are computer systems such as a PC. They are made to run word processors, browse the internet, look at my spelling there, browse the internet, and so on. Alright? Now, one other area which we may have not covered in the past is embedded systems. Now, dedicated computer systems are found almost everywhere, but when a dedicated computer system is found in electronic devices, they're called embedded systems. Alright? So you will need to know what an embedded system is for the exam. So it's basically a computer system that forms part of an electronic device. Alright? So it may be general, you may have general purpose, you may have Linux, you may have all these different operating systems, but an embedded system is found in electronic devices. So you can think of like an MP3 player or so on. Now, why are computer systems important? Well, you will need to answer that, and more often than not, they expect you to ask that and give examples in real life situations. So in safety, You may have a computer system that is used for signaling systems. So signal systems, monitoring patients, guiding aircrafts. You may have smartphone apps for travel. Smartphone, GPS systems, train timetables, flight bookings. Business, you may make orders, stock control, payroll. Retail, you might order items. Entertainment, we use computer systems for DVDs, Blu-ray, MP3 players. Communication, email, chat, social networks, business transactions. Education, VLEs, so virtual learning environments. Exam marking, sources of information online. Politics and government. What about voting in some countries? Payment of taxes. Science, number crunching, so in other words, you're looking at stats. Simulations, visualizations. Alright, so there are a number of different areas of where you need to know why we use computer systems. Now, one thing that's important for you to remember is that reliability is key. You may, in your exam, get given a scenario where you've had to talk about how unreliable the computer system has been, and you'll need to unpick and look at a scenario, and you'll need to think about why it's important. Well, computer systems particularly need to be reliable where health's involved. Imagine if you had a hospital booking system and somebody with a cold got put in front of somebody. Somebody with a cold got put in front of somebody who, for example, has cancer. So if you're in a hospital and your system put a patient with a cold in front, illness such as alright, so you've got to think about health and safety here. You've also got to think about systems where you have maybe a train. So you know where you have a train crossing. What happens if those barriers don't come down because the sensor has gone wrong? That's people's lives in danger. You've also got to think about reliability with money. What happens if the bank transfer doesn't go through? That's somebody's house that hasn't been purchased. I mean, there are examples of systems out there that you can have a look at where reliability has caused problems. Now, the other thing that you need to be aware of in computer systems, and I'm just going to insert this new slide here, is that there are a number of standards that we have to meet. So we have standards to meet. Some of these standards are called proprietary standards. If you want to continue watching this will help you in year 11, Kieran. Alright? Proprietary standards. These standards are standards that are owned by the company. So basically, if you were running Windows, okay, Windows has to work in a certain way. Alright? Now, proprietary standards, you know whether something's got proprietary standards or not because they look and feel familiar to the user. They work in a predictable way. They are also maintained by the single company. Now, one piece of software you can see proprietary standards in is Microsoft. If you think about it, every one of their products has this start bar at the bottom, and the idea of the start bar is that it means that when your customer is using it again, they're used to the familiarity of it, and they end up going and buying that piece of software again. So basically, any piece of software that you install on Windows has to have that file menu. So remember, proprietary standards are owned by the company, and they help the software run in a specific and defined way. Alright? Now, the other type of standards that you've got is there are a number of industry standards. So we've got, if I go here, Defacto Standards. Alright, now de facto standards were developed through common usage. Alright, so for example, a de facto standard that we see on a day-to-day basis is HTML. It originally started as a de facto standard, alright, and as it gained popularity, it became de jure, which means that everybody's using it. The same with PDF. PDF was originally a proprietary standard, but then it's moved to a point where everybody's using it, okay? Now, there are also industry standards. Now, industry standards are standards that are used across the industry. They're used, for example, if you've got a computer system, if you want to put something onto another computer, from one computer system to another, you can use USB, you can use CD-ROM. These are basically devices that they run across different devices now. Alright, so there are a number of different types of devices in there. Now, just to finish off this, I'm aware I've spent 15 minutes on it, we have ethical considerations that we need to think about. You usually have exam questions on this. So the first thing that you should think about are ethics in the workplace. Are you working the job you were employed to do? There are some people that are expected to take on new roles when they haven't been trained to do that. Journalists who invade your privacy. Alright? These are ethical considerations. Is it okay to log onto someone's phone just because you know their PIN number? No, it's not. We've also got energy considerations. If you have a computer system, if it's not being cooled, then it's going to use a lot more energy. It's going to be using that fan a lot more. At the same time, if you have lots of air conditioners, you're using a lot more energy. Okay, you've also got the responsibility to dispose of a computer. To dispose of a computer system, you've got to make sure that you meet standards. Particularly in the USA, old computers are, look at my spelling there, don't you love it? Old computer systems, basically, they are hazardous waste. Now that's because of the basically the materials that are in them, and they have, like, believe it or not, in some cases they have toxic materials that can actually escape into the environment. Just to finish this off, we also have a number of acts. Year 11 are learning a slightly different spec, Ben. Okay? But some of this overlaps. You will remember this. So we have the Data Protection Act, which was established in 1998. Data protection. Alright? This basically means that you are responsible to keep the information up to date. You must ask permission before selling the information or passing on the information to someone else. You must make sure that the information is kept safe and secure. You also need to make sure that personal data is protected and not passed on unless the person knows. You must make sure that you only use the information it was intended for. So if I wanted to use your information to update or get results, I could only use it for that. All right. So that's Data Protection Act. The next one we have that the current Year 11 need to be aware of is Computer Misuse Act. There are 3 laws to this that you need to consider. All right. So 3 different areas. You must make sure that you do. So the first act that you can break is it is illegal to access someone's computer system without permission. So it's illegal to access somebody's computer system without permission. It is illegal to access someone's computer system without permission with intent to cause harm. It is illegal to access someone's computer system without permission and cause harm to the machine. Now, some areas of where people may cause this harm include viruses. They may also have password crackers, brute force programs that cause harm. So these are all different areas that you can consider, okay? And that's just a quick rundown of computer systems. Now, the next thing that we need to be aware of is computer hardware. Now, there are lots of different areas of this. So we have the CPU, which is the central processing unit. All right, the CPU has lots of different areas. So I'm going to go through, for this, I'm going to go through some keywords here to remind you. All right, so the CPU is the central processing unit, and it controls all of the processing in and out of the machine. So the other thing that you need to be aware of is that it has components. Remember, it has the control unit, which works with the CPU to control the flow of data within the system. You have the ALU, the arithmetic logic unit. The arithmetic logic unit performs all of the maths such as add, divide, minus, multiply. So it provides all the maths and logical comparisons. We also have, you've got the control unit, the ALU, and these 2 areas are basically there to pass the data around. Now, I'm going to move on. Now, the other thing that you have is RAM, random access memory. RAM is volatile, meaning when the power is turned off, the information/data is not retained. You have ROM, read-only memory, which is non-volatile. When the power is turned off, the information is kept. Okay? Now, when you have the fetch, decode, execute cycle, remember what happens here. Fetch, decode, execute. The RAM fetches the instruction from the RAM, fetches the instruction. I will start that again. You have the fetch, decode, execute. So the CPU fetches the instruction from the RAM. Okay. Once it has fetched that instruction, it decodes that message and then processes it by executing it. Now, in the new spec, year 10, you're expected to go into a lot more detail than that. But basically, the fetch execute cycle is the process of fetching the instruction from the main memory, decoding them and executing them so that the CPU can perform continuously. Alright? Now, the thing that there are a number of factors that affect the performance that some of these factors include the cache. The cache stores instructions that are likely to be used more often. They are moved here so that the RAM doesn't have to keep going back and forth. Alright, the cache is like built-in memory for the CPU so that it doesn't have to keep going to the RAM, and it speeds it up. You've also got clock speed, the number of cycles / instructions carried out per cycle. Remember, this is done in hertz. Alright. Obviously, you've got kilohertz, megahertz, and gigahertz. Megahertz is 1,000,000 cycles per second. Gigahertz is 1,000,000,000 cycles per second. Now, the bigger the clock speed, the more instructions that are going to be carried out a second. So that's another thing that we need to be aware of. The other thing that you have is you have the number of cores. Alright, so you might have 4 cores, which means 4 times the number of instructions can be processed at the same time. Okay, so that's something else that you also need to be aware of. Now you need to be able to describe, so let's add another one in here. Alright, some things that you need to know. You need to know the difference between RAM and ROM. ROM, alright, read-only memory. Usually the BIOS is stored here, which will contain the boot up instructions for getting to the operating system. RAM, random access memory, usually you have parts of the operating system stored here, okay, and applications currently in use. Remember to say that, currently in use, because a lot of the time people say that the program it just runs applications, but remember, applications are installed on your hard drive until they are used. Okay, now we also have virtual memory, in case you've forgotten about that. Virtual memory, when your computer runs out of space in the RAM, the operating system allocates an area on the secondary storage, otherwise known as your hard drive, and in the hard drive the instructions that are not currently in use are placed here. Now, if the RAM increases, the virtual memory decreases because you can fit more into the RAM. You've got to remember that, alright? So virtual memory basically acts as if it is it acts like RAM, basically. The other thing that you have are, which I'm going to go over quickly, are I would like you to, I'll do this in the lesson tomorrow, so I'm going to go over, there are logic gates. You've got, I did say I wouldn't keep you too long, but you've got and, or, not. Alright. AND gate, basically both switches must be true. OR gate, only one or the other switch can be true. One of the switches can be turned on. NOT gate, whatever the input is, the output is opposite. Alright, remember the AND gate looks like a D, the OR gate is the curved gate, and the NOT gate is a triangle with a circle on the front of it. I can spend some more time and go over this in my lessons. Okay. We also have different storage media. I've got a lot to get through. Some of this I'm going to go over in tomorrow's lesson as well. But you have magnetic hard drives. Problem with these is they have moving parts. Not suitable for using with portable devices. They break easily. They can fit a lot more information on them though, okay? The other thing is that they are cheaper than the solid state. Alright, solid state hard drives have chips and no moving parts. Suitable for e-readers, MP3 players, watches. Alright, they are light. You can't fit as much information on them. They can be expensive. Alright, and then the last storage type that you have is an optical, which is stored on a CD. Good to use these because most computers have the information on them. Alright. I mean, most computers come with optical storage on them. It's cheap to get a CD, can fit 700 megabytes on them, but you've also got DVD, which you can fit about 4.5 gigabyte on, and then you've got Blu-ray and so on. So it gets much bigger and bigger and bigger, so you can get a big one in there. Right, so then we have types of software that you need to be aware of. So you have system software, such as an operating system. Now the purpose of an operating system is to transfer files between one place to another, produce an interface that the user can access, control peripherals such as a keyboard or a mouse, protect data. Alright, so there are operating systems. Now what I'm going to do, alright, is recap on some more of this in tomorrow's lesson. But what I'm going to just do is write out some key terms for you. So, key terms. Machine code. Instructions in binary used by the CPU. This low-level language. A programming language that is directed at controlling each machine operation. Interface, the way we interact with the computer system. Compilers, transaction software used to convert source code into machine code so that the processor can understand it. Interpreter, translation software that converts source code or machine code sorry, I will answer that question in a minute. The interpreter is translation software that converts source code or user input into machine code, which is immediately executed one instruction at a time. Debuggers, used to help the programmer track down faults in the program. So there are some of the key things that you need to remember. Now remember, I'll be coming to your question in a minute. Command line. Command line is an input that basically you type in the instructions and the computer runs it. Okay. The problem is that you need to know all of the commands. The other thing is that it's actually a positive. You can do a lot more to the operating system. Make more changes to security settings. You've also got voice input. Interact with the operating system / computer by telling it what to do. Think about it. We do this with our phones sometimes, like Siri. You've also got a GUI, a graphical user interface, generally full of menus so that we can choose what we want. Negative, drawback, you're restricted to whatever menus you are given. So that's something to bear in mind, okay? You also have interrupts. I'm just going to go over the last ones. Interrupts used to basically grab the CPU's attention in the middle of a process happening. Alright, so for example, if the device is required to run a different program, an interrupt will run and cut into that job. Alright, I am going to go over, I've done enough on binary. I'm going to go over that in tomorrow's lesson with you as a recap. I'm going to go over networking quickly. And then I'm going to finish off by going over databases. So, that answers your question. You have network hardware, which includes a network interface card. Terminators to prevent the signal from bouncing. you also have hubs. Hubs are basically repeaters that move the output from one port to another. They share the information / data with the rest of the network. You've also got switches. Switches, intelligent hardware that allows you to basically transmit the information to specific locations. You've also got routers. Routers allow us to work with data packets and transmit information all over the network. Alright? So with a router, it's basically let me say that one again. I kind of went blank there. Routers allow you to connect multiple networks together. For example, if I had to connect my current laptop to my school laptop, I would need a router to establish that connection. Alright? There are different models you need to be aware of. There's the client server model. Client server allows you to basically, a request is made by the client, the server then says yes or no. Then you've also got peer-to-peer. No single computer has equal status on the network. Now, what I think I would do is I'll go over the topologies. You've got bus, ring, star. Star is where you have a central switch or hub. If the hub or switch fails, the network goes down. A drawback is the hub or switch failing. Another drawback is the cabling is expensive. Strengths: the network runs a lot more efficiently. Strength: the traffic only goes where it's intended. You've got a bus. Basically, it runs a backbone, runs across the network, and the backbone, if it fails, the whole network goes down. The problem with the bus topology is that the more computers that you add, the more it slows down because the traffic is split across all devices. Ring goes in one direction, expensive on cables, allows you have lots of downtime if you disconnect one computer. So that's something to bear in mind. So they are the main topologies that you need to be aware of. Now, what I am going to go over with you is I'm going to go over databases with you in more detail tomorrow. So we are going to do that in the lesson. We're going to do a recap on data representation, and we are going to do some programming tomorrow. So I hope that's a 45-minute session you've done there. I will record some stuff that we do in tomorrow's lesson so that you can watch it back, and I will email out resources to you. I hope that that's been useful. So enjoy.